Good morning. You're welcome to today's class. My name is Mr. Kingsley Nguke. I'm here to teach on the topic waves in physics. In physics, wave is one of the most important topic because wave is applicable in every medium or every phase of life. Now let's look at what wave is all about. From the definition here, wave means the transfer of energy by a vibrating medium. You can put it that way, or you can best explain it as waves are occurring as a result of movement of energy being transferred from one source to another place around it. In wave, there is always a medium of transfer of energy from one source to another source. That's one of the best definition of wave. And in waves, wave occurs in different nature. Okay, we have wave that need medium for its propagation, and we have wave that do not need medium for its propagation. The wave that need medium for propagation, we call that the mechanical waves. Okay, what is this mechanical waves all about? The mechanical waves are waves that require medium for its transmission. Examples of this wave, we have what we call the sound waves, we have the water waves, we have the waves on strings. Then we talk about the electromagnetic wave. The electromagnetic wave, they are waves that do not need any medium. They do not need any material for its mode of transmission. Examples of such wave, we have electromagnetic wave such as light, radio, S-rays, and ultraviolence. So these are electromagnetic waves. So electromagnetic wave do not need medium for propagation. Then we now talk about the difference between these two. What are their main differences? For mechanical wave, they need medium for they need medium for transmission. Mechanical waves always need medium for transmission. Electromagnetic wave do not need medium for its transmission. Electromagnetic wave do not need medium for its transmission. So that's one of the key difference between electromagnetic and the key difference between electromagnetic and mechanical waves. So it's very important we know this. Then another difference is that mechanical waves cannot travel through a vacuum. Mechanical wave is very poor traveling in a vacuum. Electromagnetic wave travels through a medium or a vacuum. They travel in a vacuum. The mechanical waves is relatively slow. The electromagnetic wave is relatively fast. So that's it. Now we have kinds of waves. The kinds of waves, we have what we call, there are two main kinds. We have the longitudinal and we have the transverse. What is the longitudinal wave all about? The longitudinal wave is one in which particles vibrate in a direction parallel to the motion. So there's always a vibration in the direction parallel to the motion. So that is why we call it longitudinal. And examples of this longitudinal, we have waves produced by pipes and strings. Okay, waves produced by pipe and string. This is a perfect example of the longitudinal waves. Let's look at the recap of the longitudinal wave again. So I told you it's the wave in which particle vibrates in direction parallel to wave motion. Okay, so there's always a compressibility in the wave parallel to the wave motion. So examples of this, we have the strings and the pipes. So that makes what a longitudinal wave. Then we have the transverse wave. The transverse waves, they are waves which vibrate perpendicular in a direction of wave motion. So in transverse wave is all about perpendicular direction in direction to the motion, to the source of the motion where the wave is moving. Examples of this, we have water waves, we have light waves, and we have electromagnetic waves. Now this transverse wave moves in two directions, which is the crest and the crest is the upper part of the maximum width of the maximum waves. Then we have the trough. The trough is the minimum of the maximum of the minimal waves in the direction. So the crest and the trough is one of the key difference, one of the key notable parameters used in the perpendicular waves, and it's very important. And like I said, perpendicular waves moves in a direction they move in a direction, and moving in that direction, there's always a vibrating medium. It moves and also same time vibrates, dissipating energy from one source to another. And examples of it. Then we now have a very useful terminology. We have what we call the amplitude. The amplitude, like I said, is the maximum displacement of the wave. The maximum displacement, we call it the amplitude. So what we call the circle. The circle means each wave progression. As the wave is moving in a motion, the wave is completing to and fro because it's vibrating from one medium to another, then making one circle, completing one circle. If it goes again, it completes another circle. So wave moves completing a circle from one direction to another. Note, wave is a medium that transfers energy from one position to another without any permanent displacement. So there is no permanent displacement in wave. That's the reason why it moves in circle from one circle to another. So I believe this is a convincing class about wave. By the grace of God, we are going to look at so many factors involved in wave. We look at the calculations involved in wave. Thank you so much. Have a wonderful day. Thank you.